Orly, to Orly Schenker, who could not come physically here, but she agreed to give her talk by Zoom. So thanks a lot for the effort. I hope it works smoothly. Orly got her PhD from Jerusalem, and then went on to Oxford and Cambridge and the London School of Economics. I'm not sure in which order, and then the University of Haifa, the Open University, and eventually coming back to the Hebrew University, where she has been directing the Center for the History of Philosophy of Science, and she is a professor of History of Philosophy of Science. So please, Orly, let's try to see how it works.
Thank you, Alessandro, and hello, everyone. I'm sorry for not being with all of you in person and to enjoy the rest of the talks. I would like to thank the organizers for inviting me and for enabling this online opportunity. When thinking about the topic of this workshop, physics modeling of thought, I was thinking that it might be a bit useful to clarify some assumptions that underlying this workshop's title. So when we look at the title, Physics Modeling of Thought, we may ask, what is the connection between modeling thought and modeling the brain? And this will be the focus of my talk. There are various theories about what modeling is, but it seems, yeah, it works. So it seems that all these various views concerning what models are in general, all of them share something very general, which is that a model in a model will strip away some non-essential features of the modeled system while keeping some essential features of that modeled system. And by exploring these essential features, by, for example, running them on computerized models, etc., we can learn about those without the unnecessary interference of undesired features, those in which we're less interested in the modeled system. So, for example, in maps where we care less about the size and more about the relations between the objects, in billiard balls and models of gas particles, we care about some features of the interactions between the particles and less about others. And when we model hurricanes, we would prefer to leave out the destructive power of the hurricane while leaving in the model some features in which we are interested. So all these are different cases of stripping away the non-essential while keeping in the essential features of the system in which we're interested. And the question then arises, what makes something a model of thought? So the question is, what are the essential features of thought that we would like to retain in the model? And what are the non-essential ones that can be stripped away in the model? These are the two questions, or the complementary questions, on which I would like to focus in today's talk and comment briefly about them. So according to a prevalent view, which is of course not a universal view, but it is very prevalent, the essential and non-essential features of thought generally, whatever one may mean specifically by the term thought, the essential features to be retained in a model are, for example, the notions of computation. The notion of computation is a very complex one, a very non-trivial one, one which carries with it a variety of problems. But in general, this is an accepted view that something about computation is essential for the notion of thought. And many people also add that the notion of representation needs to be added in, sometimes as part of the notion of computation, sometimes, other times, separately, depending on the context of discussion. So these features are often taken to be essential for thought, whereas the fact that thought is carried out in the brain is not always seen as essential. And it is sometimes, or many times, believed that it can be left out in the model. This idea is an implication of the prevalent view of multiple realizability, namely the idea that thought and other mental processes, again, whatever you take, you understand the term thought to mean. The brain can carry out these processes, but other systems can do it as well. And of course, the question is how they do it, and in virtue of what non-brain systems can carry out the mental processes. Of course, it is more prevalent to think about other brains, for example, brains of other animals, or brains of different people, brains that undergo some significant plasticity processes. So all of those exhibit multiple realizability or multiple realization, according to a very prevalent view. And today, because we're thinking about models, the question should be, how is this view connected to the question of how to model thought? So the idea, according to this prevalent view, is that we should keep in the model the essential feature, something about computational representation and perhaps other notions, and we can leave out the details of the brain. Of course, the brain is of particular interest to us because this is the way in which thought is realized in us. But when we model thought itself, it is, according to the view that I'm discussing now, less significant and can be left out when modeling thought. The problem is that this view, the view that allows for multiple realizability, is very problematic. And in my view, it leads, or it entails, mind-body dualism. So in that sense, it is not a physicalist view, and one might say that it is not a scientific view at all. It is, of course, very prevalent, and of course, it guides research programs within science today, but nevertheless, underlying this line of thinking, underlying the very idea of multiple realization, lies mind-body dualism. I will present very, very briefly the argument for why I think this is the case, and then we will continue to our topic, namely that of models of thought. So the problem is this: multiple realizability implies mind-body dualism. For the philosophers among us, it is significant to add that this is the case even if supervenience of the mental on the physical obtains. Why is that so? Well, look at the bottom part of this slide, where we have various physical kinds, P1, P2, etc. Those are physical kinds, and the M1, M2, and M3 are mental kinds that are realized by those physical kinds. So for example, the mental kind M1 can be realized by various physical kinds P1, P2, 3, which may, as I said before, stand for different brains of different animals, maybe non-animate systems that are believed to implement thought. This is the idea of multiple realizability. And the question is this: it is well known that when this kind of relation holds, if I give you the physical kind, you can tell me what the mental kind is. And in that sense, the physical determines or fixes the mental. But the question is, what makes it the case that these physical kinds realize this mental kind? Why P1, P2, and P3 realize M1, and why is P4 not one of them, but rather a member of the M2 set of a physical kind? What partitions the physical kinds into those sets? And here are 4 families of options. I think they cover everything that there is in the literature in very general, broad terms. So one option would be that P1, P2, and P3 share some physical feature. But if that were the case, we wouldn't have multiple realization. The idea of multiple realization is that those P's do not share physical features, and nevertheless, despite being heterogeneous, they realize the same mental kind. So that is not the case. Another option would be, that the P's, P1, P2, and P3 share a context. For example, there is an observer that looks at all of them, and relative to that observer, the explanatory interests, for example, of that observer, they look the same. That would be a good account if we were to explain, for example, why different devices can serve to carry out the same computation. So your cell phone or your laptop can carry out the same computation relative to you as an observer and your interests and the way that you see them. So that would be a good account. But this is not an account, this cannot be an account of the mind, of mental processes, of thought in this case, because then the question would be who looks at the thinking objects in order to make it the case that they all belong to the same set. This will lead us very quickly to regress or to a homunculus way of thinking. So this option is not open to us as well. A third very famous, very prevalent option is that P1, P2, and P3, despite being physically heterogeneous, they share a functional role. This option, despite its popularity, doesn't work because it repeats the problem rather than solving it. Instead of searching for the common physical feature in the states or the kinds P1, P2, and P3, we're now going to look for the physical shared facts of processes. So it will be looking for shared physics over time. And again, we will return to options 1 and 2, this time with respect to processes instead of with respect to kinds or properties. So a functional role doesn't solve the problem, but only repeats it. And the fourth option, which is also very prevalent in the literature, is that these 3 kinds of brains or what have you share some brute fact. It is a fact. It is a brute fact, a primitive fact, that they belong to the same mental kind, or they implement or they realize the same mental kind. This is a kind of top-down way of thinking. We have information about the top facts, for example, the mental ones, and their connection to the low-level ones, the physical one. That's a very prevalent view as well. The problem is that these brute facts are not physical facts. The physical facts are the low-level ones. And so what we call brute facts or top-down facts are not physical facts. They are something over and above the physical facts at the low level. Therefore, this is a case of dualism. And these brute facts, these non-physical brute facts or non-physical top facts are epistemically accessible to us. We know them. We can access them epistemically. This brings into the picture a mind-body dualism. There are these facts with which we can interact. So assuming that these 4 options cover all the options that are discussed in the literature, I'm willing to discuss this further in the Q&A session if you want, because of these, because of what I just described concerning these options. The very idea of multiple realizability implies dualism. And since functionalism of all kinds, including computational functionalism, which is at the heart of research programming, cognitive science, and computational neuroscience, etc., because of this, all these research programs assume some kind of dualism, something non-physical. For me, this is a reason to reject it, or at least to take them to be somewhat non-physical. This is the fact that your ontology includes something non-physical is not a fact that you would like to mention when you apply for a research grant, for example. But this is the state of affairs in this view. Therefore, all the views that assume multiple realization, including all forms of computational functionalism, need to be rejected and replaced by something else that will not include non-physical fact. In particular, this will lead us to the well-known reductive physicalism, in which the mental facts are physical facts. And so here we need to reject all the elements of the prevalent view that I described before and opt for something that does not include the multiple realizability. This, for example, will be the idea that thought is something about the brain. Flat physicalism is a theory of reductive physicalism that I favor. I will not go into its detail. You can think of any form of reductive physicalism that you prefer. But the idea is that thought is a feature of the brain. It is not realized by the brain because there is no multiple realization. It just is something about the brain. And the question is, of course, given this idea, what then would be the modeling of the brain? Because before we thought that, according to the prevalent view, a model would retain the essential features, namely computation, etc., and would leave out, or may leave out, the non-essential features, namely those associated specifically with the brain. But this is no longer available to us because this is a case of dualism. So thought becomes a feature of the brain. And the question is, what does this imply for the idea of modeling, which is at the center of today's workshop? So the question is this: what makes something a model of thought, given that thought is a feature of the brain itself, of the biological brain, of the physical brain, depending on what material way is the way that you look at the brain. What I call physical will include biological, will include chemical, etc. So what makes something a model of thought, given that thought is a feature of the brain? And here the idea is this. The answer that I would like to offer, and then follow it by raising questions or open questions, problems, is this: a model of thought where thought is a feature of the brain is something that retains the aspect of the brain which is essential for thought. So there is something about the brain, it is in the brain, it is an aspect of the brain, it is part of the brain, if you like. That feature if it is essential to thought, if this is the feature about which we want to learn from the model, we need to retain that feature in the model, to copy it into the model. It has to be the same feature in the model, but we want to leave out the rest, features of the brain that are either not connected to thought and so only add complexities to unnecessary complications to our investigation, or features of the thought that we don't want to focus in on a given case. But the main point to bear in mind is the following: the model will copy a physical feature of the brain and leave out others in the same way that we do with respect to hurricanes. With respect to hurricanes, we leave out the destructive features of hurricanes. This is why a model of hurricanes is not destructive. But we leave in the model other features of hurricane that can still teach us something about this phenomenon. And this is, so we will leave in those features, we carefully select them, we repeat them, we copy them in our model and leave out the rest. And this is what we would like to do with thought. But then the question is, what are those features? What is the physical feature of the brain that we want to keep in the model in order to study thought? And what are features of thought that we can leave out in order to have a good model, a useful model? And here there is an open question that is implied by this way of looking at the relation between brain and thought. And the question is this: what is the difference between a model of thought and thought itself? When we discussed hurricanes, that was very easy. Or when we discussed a map, that was very easy. It was clear that the difference between a model of a city, for example, and the city itself is, for example, a difference in size, or a difference in 3 dimensions versus 2 dimensions, etc. That was very clear. But with respect to thought, we know very little, or perhaps close to nothing, about what precisely are the features of the brain which are thought. We begin to learn, of course, as you all know better than me, about these ideas, but the task is still huge. And the question, as far as models are concerned, is this: are there physical aspects of the brain? And here I emphasize physical, because we saw that, for example, computational, structural, functional aspects of the brain will not work. They lead to dualism or to homunculus ideas. They're not good for us here. So are there physical aspects of the brain that are essential for thought, and those we would like to retain in the model, but are not sufficient for thought? Namely, those features, those aspects themselves are not thought, because the trick with model is to have a model of thought which is not thought itself. So if we replicate all the essential features of thought, which will be sufficient to create thought, then we will replicate thought. This will not be a modeling of thought, it will be building thought. It will be recreating the features of the brain which are thought. But this is not the question. I mean, it's very important. It would be a huge achievement, needless to say. But if we talk about models, the question is, can we distinguish between these two parts of the features of the brain which are thought, those that we would like to model, to retain in the model, and others which we can leave out. This, when we will know how to make this distinction, we will have learned a lot about what thought is in the brain. Of course, the way is still long, but nevertheless, this is only then will we be able to have a model of thought. Thank you very much.
Thank you very much, Orly. Your slides were very clear, but also very attractive.
Thank you.
Yes, Jürgen.
First of all, Olli, I want to really thank you for. Olli, I really want to thank you for, engaging so deeply with the topic of the workshop. I mean, I can really see that you did this for our purposes, and you gave a lot of thought to the questions that we have asking. And so I can only bow in gratitude for that.
It's a pleasure. Thank you.
And I just have a question of understanding, because in the first slide where you discussed dualism, you basically claimed there is no fundamental difference between the functional and the physical. But in because you said if we assume the multiple realizability is on a functional level, then we get into the same loop as when we assume it is physical. But yes. Then, in the second part, you made a big difference between the physical and the functional. So, and it's clearly just a question of understanding. Maybe you can clarify that point.
Okay, let me try, because it's still challenging for me as well. So with respect to why functionalism repeats the problem rather than solving it. So, for example, since I come from physics, I'm familiar only with the language of physics. All the rest is mystery to me. And so when I ask, what is a function? A function is a process. It's a certain kind of process. Of course, it's a process that achieves a goal, for example. A goal is not a physical notion. Of course, it's teleological. It's not part of contemporary physics, but I leave this to the side. It is a process. A process is a sequence of physical states. So suppose that we have various processes, various sequences of physical states. And we want to say that some of them belong to the same functional kind. So we want to ask, in virtue of which facts do these sequences form a kind? What do they share? Well, if they share something that I can completely describe in terms of physics, then I'm good. But then I would say this is not genuinely multiple realization. It is a physical fact that is shared. But if these sequences do not share something physical, they share something else, for example, a goal or something like that, then we just repeat the problem. So that's it. Does this answer that part?
That's clear. Yes, it does.
Okay. 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 Good.
About the second part, and of course, I have in background the question of whether your notion of what a model does doesn't, bury the question, because if there is a model, isn't it by definition a multiple realization?
Well, if I'm very careful with my physics, I will make an effort that it will not be a case of multiple realization in the following way. According to identity theory, thought is just a feature of the brain. For example, some electrical property, it's not anything like this, but I'm using those terms just to give an example of what a physical property might be. And so if I have a particular kind of electric current which is identical with some mental process, or mental state, then I will copy this precise electric current to a different system, and it will not be a multiple realization. It will be a copy paste of the same physics precisely. Only the rest will be different, but I don't care about the rest. Okay, so this is why this is not a multiple realization.
Yeah. Orly, hi. So maybe just to repeat the question. First, I want to thank you for putting my book on the shelf, you know, so everyone can see it. So yes, and
okay, good. You see that I'm reading it again.
Yeah. Just about the multiple realization. So your claim is that, for instance, thought cannot be realized in, let's say, non-biological systems like laptops. That, and if you don't say this, so you would, do you suggest, according to, you know, this distinction between essential and non-essential properties, that, you know, the biological properties of the brain are not essential for thought? I mean, so, yeah.
So there are two ways of looking at the question that you raised. First of all, if, for example, a certain mental state or process is, for example, our little electric current. If I have this particular electric current in a laptop or in my car, then thought will be in that system because it will be identical in that sense. So I'm not against replicating thought in non-biological systems. Quite the contrary. It is a straightforward, I mean, not a simple, but not simple to discover what is this little electric current. But once I identify it, I can replicate it in principle and implant it in non-physical systems. But that, in that case, it's not, the fact that the system is a computer is not essential. It may also serve as a computer, you know, for certain users, but the reason in virtue of which, I mean, the fact in virtue of which it will be thought or implement thought will be that it has in it the exact same physics, this little electric current that I have in my brain, exactly this, and it will not be about computation as such. So in this sense, laptops can implement thought, but you know, it's no longer interesting that they are computers.
But also the biology is not essential,
right? I'm not sure at this point. I'm no longer sure what's biology. I mean, if thought is implemented by this little electric current, then is this biology or not? I'm not sure. If it happens to be the case that thought is identical with some biological structure, something that is very specific to biological, some of those typical molecules, etc., then it will be biological. And then if I want my laptop to have thought, I will have to implant in that laptop these biological molecules. Whatever that is, whatever it is in the brain, which is exactly identical to thought, I can put it anywhere. And at that point, the notion of biology is perhaps no longer central. So this is a very good a point to, I think, to have in mind, the point that you raised. I didn't think of it in these terms before. So I think it's a very good distinction to be made about this.
There's a question from Chaim.
Hi, thank you, Orly. I have two questions, and I think they're related. One is the same criticism you might say about, I would say, any study, entire biology. Most biology study systems and attach them to functions and you can ask whether the heart is pumping blood, or if you take the same electrical activity of blood muscles and build on my laptop, then my laptop will be heart or not. So it's a general question. One thing, and the other one is your solution seems. I'm trying to understand what is there any message to the scientist here, to the neuroscientist? I think all of us will be very happy with discovering what is essential in the brain to generate biological thought. So is your message about philosophy, or there is something which will actually guide us or change our methodology about our practical research?
Thank you, Chaim, for two very great questions, very deep ones. Let me begin with the second, the message to scientists. So the message is can be stated very simply, but it's not a simple one. The message is, do not search for computations. Search for physical processes. Because if you search for algorithms, for example, those that can be realized in other systems and so on, this, if physicalism is correct, if the world is not dualistic, then you will not find the mind there. You will be able to build great robots, etc., but you will not find the mind in the computation if the world is not dualistic. So that's the message. If scientists believe that the world is physical and the mind is somehow physical, then computational research programs are on the wrong track. That's the simple but not simple message to science.
But is it so? Is studying the blood the blood circulation function of the heart? Is it justified? I mean, let's take out the word computation and the word mind, because we don't write papers on minds, neuroscientists, but we are trying to understand perception, vision, auditory processing. We're trying to understand decision making, control of motion. Is it justified or not?
I think those projects can be justified. They're very different from the search for the mind, and they can be justified in the sense that let me follow your example about the heart, as for example, natural heart, biological heart, and artificial heart. When we build artificial hearts, what we build is a pump. Now, is the biological heart, is its function to pump blood? Well, it depends. It depends on how you look at the heart, and if your interest is, for example, to save the life of somebody. This is a goal that you have. Nature doesn't have goals. Nature does what it does, including in evolution. This was Darwin's, of course, very revolutionary idea. There is no goal. Things just happen in a way that is convenient for us human beings with our minds to think of in terms of functions. Now, so here you can look at the heart. The heart is a physical system, and you can replicate some physical features of the heart. It's not a function in some abstract sense, in the sense of goal. The artificial heart has a physical feature that replicates some physical features of the biological heart. You do that, you copy paste that feature, and you care less about the rest. So in this, you could think of the artificial heart as a model of the biological heart in that sense. And this is about what you are interested in. It's not something internal there. This is why it is different from the mind. There is no danger of homunculus with respect to the heart. Sorry?
So can we build an artificial brain as a model of the physical brain, which will explain some of its functions, because that's what
Yes.
artificial brain is doing. And
Yes.
can we do it in the brain, in neuroscience?
Of course, I mean, if there is a feature of the brain, for example, some part of the activity of neurons, you focus on that physical feature of the brain.
I'm
and you
talking about
replicate
cognition.
it.
I'm talking about cognition.
Well, so this is cognition in the sense of well, it depends what you call cognition, but whatever it is, if the world is physical or material and is not dualistic, then that thing must be a feature of the brain. And if you find this feature of the brain and copy paste it, you will have modeled or replicated, depending on the case, thought or cognition. This is not, but you will have to replicate, to copy paste the exact physics that does it, to identify and replicate it. This is a research program, which is physical and not problematic. And those who carry this out are doing materialist science. It is not a problematic program. The problem is only when you look for algorithms. That's not physical.
I think we have to give the floor to our convener.
No, just very shortly, I mean, the strength of your argument rests on the exclusion of dualism. That's your demon, so to say, to appeal to the book that you have on the shelf. But if you take Phil Anderson's position, you know, the alternative is not just between a holistic, physicalist view and a dualist view, but it's a pluralist view of the world. So would your argument still work if you admit that there are various levels of reality to be described by different equally scientific frameworks?
I'm careful about the notion of levels of reality in the following sense. There is a very useful distinction between the micro and the macro, but that if you look at it in the following way, it will explain what levels are. So a micro description of the universe, as it is understood, for example, in statistical mechanics, is a complete description of all the details of a system, for example, at a given time. Now, if you focus on only an aspect of that system, for example, the average position or average kinetic energy or something like that, this is a partial description of the system, an aspect of it, if you like. And when you look at the system, for example, if the aspect is average kinetic energy, we feel that aspect when we put our hand in a warm gas, we feel that particular aspect. This is not another level of reality. You touch directly the microstructure which obtains in the world at that time. You only feel only part of it. So what is often seen as levels of reality is actually parts of reality. So those are, okay, so.
Last question by Yuval.
Hi, Orly. Following up on Jorgen's question and repeating a question you've heard from me before. So you are very effective in setting up this fourth choice between radical physicalism and dualism, and nobody wants to be labeled a dualist, but you don't really leave a way out, because it seems to me that even something as basic as noticing the two identical but numerically different laptops have something in common already commits me to a kind of dualism. I mean, in your answer to Chaim, you said you have to copy and paste the physical structure, but unless I take the actual material, what I abstract from it already any kind of abstraction or finding something common that cannot be identified with the matter itself already kind of commits me to dualism, doesn't it?
Well, to answer. First of all, dualism is not a pejorative term. It's a view, and I don't know whether it's true or not. What I'm asking is, what are the implications? And we should be clear about our commitments. And if we are dualists, then fine. I mean, I'm sure that you, Yuval, do not hesitate to mention dualism in your research proposals for grants, but other people may be more worried about this. So that's about dualism, and it may be the truth about the world. I'm not saying about anything about that, only implications. Second, about two computers, for example, your laptop and my mobile phone. Why do I think, and correctly so, that they implement the same computation? In what sense? I mean, they are physically, let's say, even heterogeneous. So those systems, I mean, if they were in outer space, and supposing that they are really physically heterogeneous, then an alien, for example, which is not human, it doesn't have human senses and the human brain, would not recognize them as doing the same things because they do not do the same thing. They are heterogeneous systems. But when we look at them, we focus on certain features of them that create brain processes in our brains that make us see them as doing the same thing. They are not the same systems. If you take an animal that has different senses, for even a different different kind of vision or something like that, they will not think that these two systems are doing the same thing. Computers are built for us as users, and the engineers who build them take into account our capabilities and the way that our brain is operating and sensing and thinking about things. So this is not a case of dualism, but it is available to us only in order to understand why two laptops or two kind of devices that serve as computers, why those are the same. Then we as observers make it the case that they belong to the same kind. But this move is no longer available when we're talking about our minds, because there is no observer that makes it the case that I carry out a certain process. I'm the last stop in this process. So this is no longer available for the mind.
Thank you very much, Orly. I want to thank you, but also our technical experts for a very, very polished Zoom interaction. Thank you very much.
Thank you. Thank you all very much.
Now we have Kanaka Rajan.